Well, hello class. Welcome to chemistry. I hope your day is going swell. Today we are going to look at atomic structure, do the nuts and bolts of the activity, and it's basically this is the main part of the chapter. So we're going to focus on it. We'll try to go slow. We'll try to review in between. So if you're missing today, you can kind of keep and follow along as we go. Okay. So first off, we're talking about atoms, atomic structure, and before this class, we did a bunch of stuff on like history. So like what did John Dalton do? What did J.J. Thomson? What did Ernest Rutherford do? And so we understand right now currently that the atom is composed of three subatomic particles. And, we have to kind of know their locations, where they're at in the atom, and their relative masses. So the protons, they're located in what we call the nucleus, where all the mass of the atom pretty much is. Its charge is positive. Maybe you remember that from freshman year or from before. And it has a mass of what we call 1 AMU approximately. So 1 AMU is what we call a atomic mass unit. And that's basically where in the nucleus the protons are. So sometimes we'll write the abbreviation P plus because they're positive and they're protons. That's what we use. So neutrons, they are also located in the nucleus, and they are about the same size as the protons. They are abbreviated N0 because they have no charge. So they are non-charged, but they actually have an important role in the atom and structure, and we'll get into that in this unit as well. They have a mass of 1 AMU, and they're about the same size, like I said, as the protons. So the neutrons are about the same size. And then we have E minus, the electrons. They're located in what we call the electron cloud, and they have a charge of minus, and they're equal and opposite to the proton. So if you have one proton and one electron, there's no net charge. So they kind of cancel each out. And their mass is approximately 1/2000th of an AMU. So they're super small. In fact, we really don't even count them for mass when we typically do the mass of these things because they're basically considered a quark. Okay, really tiny. Okay, so now the atomic number when we're doing a structure, so you're going to be given an atom on the periodic table, something like carbon here or iron, and you're going to have to use the atomic number, which is that whole number located. It's the blue number on our periodic table, but it's right there, right here. So this is like the address of the atoms. The atomic number is actually the number of protons. Okay, now this can be confusing to some students because the abbreviation for atomic number is Z. So the atomic number Z is the number of protons. So carbon literally has 6 protons, and iron has 26 protons. And if you look on the periodic chart, like if you look at, uranium, you can see it in the top corner, has 92 protons. So the atomic number gives us the number of protons in the atom. And if you take that away, if you take one proton away, it is no longer that atom. So if I have and take away 1 from iron somehow, and you have 25, well, that's manganese, which is a different atom. If I had to take away 1 from copper, that's 5. That's boron. So each atom has its own specific number. Think of it as an address, and that is the number of protons. Okay, that never changes. Well, I mean, it can change, but it changes the identity of the atom. Now, in a neutral atom, and most things that we'll deal with are neutral, the protons equals the electrons. So, for example, in a neutral atom of carbon, you have 6 protons and 6 electrons because they kind of cancel each other out. But we'll find out later that you can have something called an ion where they're not equal. Okay, now next, to find the mass, and oftentimes you'll be given things like this down here. So these are what we call the mass number. So the mass number is the number of protons plus neutrons. So A is equal to P plus N, okay, where the protons is the atomic number. This should be N0. And the neutrons, well, that's the number of found in a nucleus. They usually have to give you that. So when you're doing this kind of stuff, the mass number is often written at this part of the atom, or sometimes it's written like this. It would be C14. Now tomorrow we're going to go over what isotopes are, but just know that the mass numbers can change for now. So if I'm trying to find how many protons that an atom of carbon has, it would have 6 protons, right? And if I'm trying to find my electrons a neutral atom would have, it would have 6 because these two are equal. And to find mass number, okay, so if I'm given mass number and I'm given atomic number, so the mass number is 12, the atomic number is 6, do you see that the number of neutrons would be 6? Now, usually this number is not always the same as these two. In fact, most of the time it's different, but sometimes in smaller atoms, they're the same. Okay, so you're going to have to find the atomic number, which is that blue number on your chart. You're going to have to find the mass number, which is going to be given to you on the top here or on the back side. Like this one would have 8 neutrons because it has 6 protons because it's carbon, and it has 14 minus 6 would give us 8 neutrons. It's called an isotope, which we'll get into tomorrow. Okay, so that being said, you're going to have to take something like this and reverse it and write the complete chemical symbol. Okay, so for the complete chemical symbol, and again, we're going to go over all this in class, a little bit more review. This tells you what atom it is. So does everyone see on your periodic charts that 7 is nitrogen? Now, some people just write N. Like you don't necessarily need to write that 7 down there unless you're asked to. And that the reason is that N is always 7, so it's like assumed. Okay, now up here goes the mass number. So the only two with masses are the neutrons and the protons. Okay, so this would have a total of 15 neutrons. And then the electrons and protons are canceled, so there's no charge. If there was a charge, it would go up here because those are what happens with ions. And we'll talk about that in just a second. Let's do one more. Let's say that you have 14 protons, 16 neutrons, and 14 electrons. What would your symbol be? Okay, so this tells us, we look at the protons because the atomic number tells us that Si is number 14. And again, you could put that down there. It's sometimes assumed. You don't always have to put that down. And then do you see how these are the only two with mass? These don't have mass. The electrons are so small. So you add those up and you get 30 as that. And then it's not an ion, so that's what you would do. And then the reverse of the process, if again, I had 16, 32, and S, this would tell us how many protons I have, 16. The difference between these two tells us how many neutrons I have, which would be 16 as well. It's 32 minus 16. Again, neutrons is always equal to the atomic mass minus the atomic number. Protons is equal to Z, and electrons, we're going to find out, is equal to the atomic number minus the charge. Now, since this has no charge, it's just the atomic number. So this part is just the atomic number. So it would have 16 electrons. Okay, let's keep going. We're having too much fun. Okay, so this is the last little bits on ions. So when you are an ion, what happens is you are a charged particle. And ions, they're charged particles. And what happens in ions is, so charged particles, is protons do not equal electrons. So in a neutral atom, they equal each other. So in a neutral atom, protons equal electrons, but ions occur when protons do not equal electrons. So an example of this is like something like this. So you might have Na, which is 11 and 23, and it's plus 1. Okay, so what happened here is in an ion, they either gain or lose electrons, and so you have to figure it out based on the charge. Okay, so if you're positive, that means you have more protons than electrons because protons are positive. So positive ions, they're called cations, and they lost electrons. Anions, okay, tend to gain electrons because they're going to be minus. So this would be an example of, oops, that'd be a 9, this would be a 19. Okay, so you're going to take a look at an ion, and you're going to have to figure out how many protons, neutrons, and electrons are present in an ion. Okay? All right, so let's see if we can find the net charge. So if you have 6 positive protons, first of all, you'd be carbon, because the number of protons in carbon is 6, and you had 4 negative electrons, your overall net charge would be plus 2. It would be plus 2. So you would write C plus 2 up here. So the charge goes up here. That's the net, overall net charge. This would be 6, and we don't know the mass numbers. They didn't tell us that. So let's say that you have 7 positive protons and 8 negative electrons. So now electrons wins. You have more negative charge. So you would be, number one, you would be 7, which would be nitrogen, and you would be -1 because you have one extra electron. So to find electrons in a symbol, what you do is electrons are always equal to the atomic number minus the charge. Okay, so let's say that you have calcium and it's 20, and let's say it's 41 and it's +2. So to find the number of protons, it would have 20 positive protons because that's the number of protons. The number of neutrons is A, the atomic mass, minus Z, the atomic number, so you would have 21 neutrons. And the charge, it's on the video, it's not for real, don't leave the class yet. Okay, and the charge would be atomic number, so 20 minus 2, which would give us 18 electrons, which makes sense, right? You have 20 positive protons and 18 negative electrons, so that's why it's +2. Okay, so we're going to be practicing this. I don't expect you to know it all right now, but here's what you should be able to do. You should be able to take a complete chemical symbol, and let's say it's like 6 and 14 and C and it's +1, and you should be able to find that it has 6 positive protons, 8 neutral neutrons, and then 5 negative electrons, right? Because you have a charge of +1. And then vice versa, you should be able to take, let's say you have 2 positive protons, 3 neutrons, and 1 electron. You should be able to write the symbol, which would be helium, because it's 2. This would be 5 because these two have mass, and this would be +1 because there's 1 extra proton. If you could do that, you're going to be golden. All right, so we're going to wrap it up. We're going to practice in class. I hope this makes sense. If not, get help. We'll figure it out. All right, let's end this video and let's call this video done.